The new Dunites is a site-specific research project in the arts investigating a culturally unique and biologically diverse location on California's Central Coast. Here, in one of the largest intact coastal dune ecosystems on Earth, is layered an intricate history spanning the real and the simulated, the human arts and nature's methods. Buried beneath these sands, upon which endangered shorebirds nest, and where free-thinking artists once hand-built a new community, lie the remains of one of early Hollywood's most extravagant silent film spectacles. In 1923's The Ten Commandments, director Cecil B. Demille transformed these coastal dunes into desert, building atop them a stylized Egyptian palace of immense proportions. In this project, we investigated and reconstructed some of the many histories of this complex place, using an array of tools and methodologies drawing from geophysics, archaeology, cinema, history, computational media, and art practice. We gathered data in the field using devices of our own design in addition to commercially available platforms, and we presented the results of our explorations in an interactive installation consisting of an ecology of interfaces, a system allowing scientists, artists, and others to experience the archaeology of media in illuminating multimodal ways. The Ten Commandments was the most expensive film ever made at the time of its release. Over 2,000 extras, 4,000 animals, and 400 carpenters were brought in by train to the monumental set, which featured the Pharaoh's palace and an avenue of 24 giant sphinxes. In the film, the site is featured in the Exodus sequence as Moses leads the Israelites on their journey out of Egypt. According to DeMille's autobiography, as filming neared completion, a decision was made to destroy the entire set to prevent rival production houses from using it. The set was dynamited, and the sphinxes were pushed into trenches carved into the dunes. Now, 90 years after ancient Egypt was buried in the California sand, the effects of wind, water, time, and technology are revealing its secrets. Our primary goal in the field was to acquire information about what lay below the surface of the dunes. Due to the sensitive nature of the site, excavating was not possible. Instead, we used a modern piece of non-invasive technology called ground-penetrating radar, or GPR.
It works very similar to the radar that is used at airports, where you generate some electromagnetic energy as it travels through space. It encounters some object, and you'll get some reflection off of that object. With ground-penetrating radar, we do the same thing, except that we force all the energy into the ground.
GPR provides a three-dimensional data set telling us the story beneath the surface. We conducted a GPR survey of an area roughly 60 meters by 35 meters in size. But first, we decided where to look. And to do that, because of the irregular slope of the dunes and because of the amount of material protruding through the surface, we took to the air. Open source designs for tools for performing so-called citizen science are becoming more and more popular on the web. The prevalence of a hacking and customization culture today means that when we wanted to build a platform for aerial photography, it was as easy as searching for examples on the internet. Similarly, for instructions on how to convert a cheap digital camera into an infrared imager. For only a few tens of dollars of materials and helium, we were able to obtain a high-resolution, multispectral panorama of the site from 100 feet up. The aerial images guided our decisions, and over the next 2 days we gathered data, flashing our electromagnetic beacon into the Earth at the speed of light, downwards into the past. Our first interface is a real-time computer graphic visualization of our ground-penetrating radar results. Users can navigate around a virtual reconstruction of the subsurface features and can select the specific radar data presented to them. In this view, for example, at low radar reflectance, the diagonal stratigraphy of the dunes is visible. However, by showing only high radar reflectance intensities, the dune's structure is removed, and here we see evidence of the presence of buried structures, arranged in a line and extending to a depth of around 10 feet. Moving a horizontal plane shows features of interest by depth in the smaller window in the top left. Ground-penetrating radar works by arranging successive slices of electromagnetic information into a volumetric dataset. Inspired by this concept, we designed the second interface in our installation, which applies the logic of the context-free nature of digital data to the Ten Commandments itself. Successive frames from the film, arranged sequentially in space, are extrapolated into a three-dimensional surface. This representation halts the cinema's requisite passage of time and instead recasts an ephemeral moment of narrative into a navigable, timeless environment. Inhabiting the visualizations, and indeed nesting within the data itself, is a flock of synthesized snowy plovers, whose virtual songs and calls are amplified throughout the installation. The third interface consists of built objects, two laser-cut acrylic sculptures created by spatially sequencing slices of data. One object visualizes a portion of our ground-penetrating radar data, demonstrating subsurface features and dune formations, while the other object is made up of successive single frames from a 10-second sequence of the original Ten Commandments film. Our final interface is an iPad tablet. Using multi-touch gestures and the tablet's built-in gyroscope, users can view the GPR data as a virtual volume. Users are encouraged to inspect subsurface features from any location and at any angle. In February 2012, the new Dunites installation showed at the University of Santa Barbara's Experimental Visualization Lab as part of the Media Arts and Technology seminar series. The future of the dunes, and of the ruins beneath them, is uncertain. As the dunes continue to migrate inland, they expose layers of the past and splinter them into memory. Archaeologists disagree over the value of the information buried here. It's a site that comes to us not only from the era of written history, but from the age of the recorded moving image. What value could there be in excavating these Hollywood replicas of our cultural narratives when thousands of other cultural treasures go unpreserved and unexplored? The answer to this question, for the time being, remains to us as elusive as the riddle of the Sphinx. But through experiments in media archaeology, using the non-invasive potential of modern technology, and by presenting new ways to experience our multidimensional past, we hope to encourage the preservation, appreciation, and exploration of this unique place and of others like it.